We're going to talk about the trapezoidal rule. The integral from a to b of f of x is b minus a divided by 2n, where n equals the number of rectangles or the number of partitions. And it's always f of a plus f, that is f of our x0, which is a, plus f of x1 plus f of x2, all the way up to f of xn plus f of xn, where xn is b, except with the exception of the first term and the last term, the middle terms are all being multiplied by 2. Okay? All the middle terms get multiplied by 2 except the first and last. So suppose that and this is an approximation. Suppose we want to approximate the integral from 3 to 5 of x squared dx, where n is 4. Okay, so n is 4. So what would this first part be? It'll be b minus a divided by 2 times n, which will be, well, that's going to cancel out with that. 2 over 2 is 1 quarter. Okay, so our b minus a over 2n is 1 quarter. Okay, so let me write down the 1 quarter. Now, what is xa? x0. x0 is 3. Now, x1, so what is delta x? Delta x is just b minus a over n. It's 5 minus 3 over 4, which is 2 over 4, which is 1/2. Okay, so what we have is that x0 is a, and x1, well, I add a half. It's 3 1/2, or 7/2. And x2, well, I add a half. It's 4. And then x3 would be 4 1/2, or 9/2. And then x4, add a half to 4 1/2, you get 5. And that's where we stop. Okay, so we know that, and this here is f of x. And what does f do to what's inside the parentheses? It takes it and it squares it. Very simple job. So first, I'm going to square that number, but all the others get 2 times. Then I'm going to square the next number, which is 49 over 4, plus I'm going to square the next number, 2 times the next number, always 2. 2 times the next number is 16, plus 2 times 9/2, which is 81 over 4, plus, this is the last one, so I don't multiply by 2, and I get 25. Up to doing the arithmetic, here's our answer. Okay, well, this goes into 4 2 times. This goes into the 4 2 times. So this is 49 over 2. This is 81 over 2. When I add 49 and 81, I get 130. Divide that by 2, I get 65. Plus the 9, plus 32, plus 25. Well, Well, this plus this is 90, plus 9 is 99. That's like 100. Oops, equals. 100 plus 32 is 132. But I cheated by calling that a 10. It's really 131. And then I need to divide it by 4. So the answer is 131 divided by 4. And this is 32. What's that? 128 and 3 left over. It's 32 and 3/4. Okay, I squared that number. I squared that number and I multiplied it by 2. I squared x2, I multiplied it by 2. I squared 9/2 and I multiplied it by 2. And the last value I just squared. Don't let this scare you. It's rather simple. Suppose you have the integral from 6 to 7 of x plus 1 dx, and they tell you that n is 4. Okay, so in front, we're supposed to have b minus a over 2n. That is, the first thing we write is b minus a over 2 times n. b minus a over 2n. Well, this is 1/8. Okay, 1/8. And now we just want to know what delta x is. Delta x is b minus a just over n. 7 minus 6 over 4. It's 1/4. That tells me that x0, that's going to be the lowest number, 6. And then I add 1/4. x1 will be 6 1/4. x2 will be 6 2/4, which is 6 1/2. x3 will be 6 3/4. And finally, x4 will be 7. And it ended up perfectly. It ended up at 7. Now, that's f of x. All it does is it takes x and it adds 1 to it. So I'm going to add 1 to that value, the first value. The second one gets 2 times. I'm going to add 1 to that value. I'll get 7 1/4 plus 2 times. I add 1 to that value. I get 7 1/2 plus 2 times that value. Oops, 1 more than that value. That's what the function tells me to do. It says take x and add 1. Plus the last one, I just add 1. I don't multiply by 2. And there is your answer. Now it's now it's a pure arithmetic problem. So this is 1/8. 7 plus this here is 29 over 4. When you multiply it by 2, it becomes 29 over 2. This number is 15 over 2. When you multiply it by 2, it's just 15. Plus, this number is 28, 31 over 4. When you multiply it by 2, it's 31 over 2. Plus 8. So here's my 1/8. When I add those two numbers, they have a common denominator. The numerator is 60. Divided by 2 is 30. Well, this plus this is 15. Plus another 15 is 30. And those two added up to 30. So I'm going to get 60. And this becomes 15 over 2. This becomes 15 over 2, which happens to be 7 1/2. Oops, have one error here. Big error. We should say that it's approximate. Actually, I think it's going to be exactly that. Think it's going to be exactly that. Okay. And we could do this based on what we did in the last section. We can integrate separately. That's x to the 1. It's x squared over 2. And you know, whatever goes here when you take the derivative should give you 1. So x should go there. And we're evaluating from 6 to 7. So we get 7 squared over 2 plus 7 minus 6 squared over 2 plus 6. Okay, these two have a common denominator. When you subtract them, you get 13 over 2 plus 7 minus 6 is 1. Now this is 6.5. And when you add 1, you get 7.5. 7.5, which is exactly what we got before. But you don't always know that you're going to get equality. Since this was a nice line, we got equality. But the trapezoidal rule doesn't guarantee this. Okay, go over these two problems. They're all the same. Find out what b minus a over 2n is. Find out what b minus a over n is. Because that's what you're going to do to find what you have to take f of. Okay, you start off with a, and then you add delta x. 6 plus a quarter is 6 1/4. Next one, add delta x, add another quarter. That's 6 1/2. Add another quarter. That's 6 3/4. Come on, if you got $6 and I give you a quarter, you got 6 1/4. I give you another quarter, you got $6.50 now. I give you another quarter, you have 6 3/4. $6.75, 3/4. Then I give you another quarter, you have $7. So you can add a quarter to numbers, to integers. And just know what the rule is saying. The rule is saying whatever x is, add 1 to it. Okay, whatever x was, I added 1 to it. Okay, I added 1 to that. I got 7 1/4, which is what I said here. Then I added 1 to this number, and I got 7 1/2. And I added 1 to that number. I got 7 3/4. I added 1 to the next number, and I got 8, with the exception of the first and last number that just get multiplied by 1. All the other numbers got multiplied by 2. Okay, know the rule and just take f of, now that's f, take f of this number, take f of that number, take f of all of those numbers, and you get what you get, and then you're done. Okay, next video is going to be on Simpson's rule, another similar process, just a different formula.